So we are now being recorded. Once again, good morning and welcome to, this is the maiden, the first lecture for this course. So I welcome you. So I've activated the attendance tracking, so that will allow your attendance to be automatically tracked. So this is our Google Classroom page. So if you have already, if your name appears now, it means you are you have been registered as a bona fide class member. Is Osaremen around? No. Is Osaremen around?
No, sir.
No, I think it's the only one, not around now. Is there any other person around that is not yet registered? Is there any other person in attendance but not registered? I don't think so. I think
no, sir.
Abioye is here, Ese is here, Ahmed is here, Joseph is here. So you are all welcome. Then I must also let you know that apart from my humble self and of course your chief servant, I have other eminent colleagues who are working on their PhD in this area. So they are joining me. So they will be assisting in this course. So Peter, you want to introduce yourself properly?
Thank you, Prof. So I'm Peter, Prof student. We will be here together to look at how to, dig deep into statistical data mining. So thank you, Prof, for giving me the opportunity.
Thank you for accepting the opportunity. The other lady, Honey, I hope she will join. Maybe she's still in the mood of the season. So this is our Google Classroom. For those that have taken my courses before, you know how we operate here. So anytime we have the lecture, this is where you come, and then you just click the join icon to be able to join the classroom. Yes, Joseph.
Oh, I'm sorry to cut in, sir. Future Ubokobong is unable to join the Google Classroom page, sir. If we can get the link to send to the WhatsApp group, I think that would help.
It's on the WhatsApp group now.
Why? Why is it not able?
You should be able to join.
Let me be said. It's on the WhatsApp group.
What is this?
It's on the WhatsApp group.
What is his email? Do you have his email?
No, sir, I don't. But I would ask him now. I would ask him on the group chat, sir.
Okay, well, Peter can handle that for me. So if there is any issue, just type on the chat menu to save time. So then, so I was saying that for those who are already used to the Google Classroom, you will always come here, click join to give you access to the to this classroom environment where we have the video recording. Then the classwork page, that's where you will see resources for this course. The data set, for instance, the course synopsis, you can see them here. The course detail, as in the curriculum, the outline prepared for the delivery, and of course, so far we have uploaded 2 lectures. I don't know how far we will be able to go today, but the essence of uploading the lectures ahead is that you should be able to also prepare and read and also put down your questions to make the class a bit more interactive, so that it's not just one-sided. So here you have the people, and then you won't see this in your own because you are not the teacher. So, but you see stream, classwork, and people. Now let's go to what we have for today. This is the course outline. So the first lecture, we are going to introduce ourselves to the concept of machine learning and that of data mining. I'm sure some of these concepts, they are not new to you. Well, it may be that the depth of what you know is may vary, though. So perhaps it's going to be a bit deeper now. So under this introduction, we are going to learn, have overview of machine learning and its significance in data mining. That tells you there is a connection between machine learning and data mining. So remember, the course itself is statistical data mining. So you will also see what the connections are. We are going to look at different learning techniques: supervised, unsupervised. We also have semi-supervised. Then we will round up the introduction with key issues, and we highlight challenges in machine learning. It's important that we know those key issues and challenges so that we don't think that everything is perfect. No, there are challenges here and there. Lecture 2 will focus on best subset selection regression. 3 will focus on penalized regression. 4, partial least square. I'm sure you are hearing some of these ones for the first time. Logistics, maybe you are familiar with it, I guess. Discriminant. So we'll be able to go to far, depending on the time we have. So if time permits, then we can go to the very last topic. But wherever we are able to, whatever we are able to accomplish, it will go a long way to really give you a very solid foundation. So let's go straight to, except you have a question. If you have a question, let me know. Otherwise, I want to go straight to the very first one, which is Introduction to Machine Learning and Data Mining. So, as I said earlier, this is the gateway. This first lecture is like the gateway to expose you to the world of machine learning and, of course, data mining. So you are going to have a foundational knowledge. Three key objectives that you should bear in mind in this first lecture. One is to understand the basic concepts. There are, just in any field, in any discipline, there are basic concepts, terminologies that one must be accustomed with. So we will do that. Then we will distinguish between supervised, unsupervised, then semi-supervised. So we will. So at the end of the lecture, you should be able to also distinguish between them. And as I said earlier, what are the key issues? What are the challenges as far as machine learning and data mining are concerned? Those issues will be brought to our attention. Issues around data quality, issues around dimensionality reduction, model performance, issues around overfitting, underfitting, ethical considerations, and other issues relating to bias, and so on. So those issues will be discussed. So these are the key points in this lecture. So let's go straight to, but feel free to stop me to ask questions if you have any. So, Introduction to Machine Learning is a branch of artificial intelligence. So, whether you talk of machine learning, data mining, statistical mining, wherever, deep learning, these are all they are branches, of they are all a branch of artificial intelligence. So artificial intelligence is quite broad, very wide, but it has branches. So the machine learning is all about making predictions. It's all about making computer to learn. So when you see that word machine, it's talking about the computer, the algorithm, whatever, to learn and operate like human, so that they can reason like human, and also take decisions the way humans take decisions. You know, we all grow up and we learn. Sometimes we make, uh, when we are wrong, we are corrected. And then we won't commit that mistake again. That's the same way. So the machine will be trained and then used to predict. And if the prediction is wrong, then the data is updated and then used for future prediction. So the process is just as simple as that. But in terms of my definition, so it's just machine learning is just science, as you want to say it, and it's the science of getting computers to act without being explicitly programmed. So you now have self-driving cars. You know, these are products of artificial intelligence. You have practical speech recognition. You know, these are outcome of these are products of artificial intelligence. So you are typing on your phone, and your phone is suggesting the next possible words to you. It's predicting your next word. So that is also artificial intelligence. So, and that is so pervasive today. So you can barely do anything without you using artificial intelligence. So, but what are the core concepts? From the word, learning is very important. So learning is the process by which machine learning algorithms improve their performance on the task with experience over time. I've demonstrated that the way humans also learn. So the way you are learning now, you know, so you are taught in the class, you are examined, and you see your corrections, and then you are able to make changes, and in the exam, you know, maybe the test you have seen the corrections, then in the exam you see the same thing, and you definitely will not make that error again. So that's learning. Learning involves being trained and then being tested and then being validated. We'll be talking more about that. So, but the other thing is model. For those of us, we are all statisticians, so we talk so much about models. Models are mathematical representations, and they represent the real world process. So you are familiar with linear regression model, you are familiar with logistic regression model, whether in your econometrics simultaneous equation model. So we use model, and statistics actually develop models. Most of these models are used in machine learning. And so another concept is algorithm. Algorithm is very important. They are set of rules, and they are also statistical techniques used to learn, patterns from data and make predictions. Sometimes your model will also be your algorithm. So whatever you consider a set of rules, they are regarded as algorithms or statistical techniques. As long as they are used by the computer to learn, to detect patterns in the data and to make predictions, they are algorithms. They are algorithms. So the next concept which you must learn is what we call the training data. We use data a lot in statistics when we develop the model. So we have to use data to uh, uh, to uh, to see whether there is compatibility between the model and the data. So in machine learning, we have the training data and we have the testing data. So our data sets are usually in two groups, but we can still have more. We'll talk about that later. Generally, the training data, they are used to train the machine learning model or the algorithm, as the case may be. So, so in that data, you will have both the input data and also the output data in the training data. But in the testing data, which is used to actually test the performance of the model. So you sometimes also your testing data may be a new data completely. So it's going to be data that the model did not see or that was not used to train the model, to be a new environment, to be a new data set completely. So that's the testing data. So the training data is used to estimate the model. So now if I want to use statistical language, the training data is used to estimate the model, but the testing data is used to evaluate the model. So that is the simplest way of putting it. So we have 4 different types of machine learning that we'll talk about, but they also depend on. Let me introduce you to so let me activate the whiteboard. I hope you are still with me.
Yes, sir.
Okay. So generally, before I give you the different types of machine learning, in our data set, we are going to have, we'll have set of input variables. So input variables could be x1, x2, So xk. So these are input variables. And of course, you could also have the output variable. So in statistics, the input variable, they are usually called the explanatory variable, the regressors, the independent variables, so to say. The output variable, you usually will use Y to represent them. So you could have more than one output variable. So, but in most cases, in linear regression, for instance, you could have several input variables, but you will only have one output variable, which is your dependent variable. This is it's very important you understand what the concept of input and the concept of output variable. So to distinguish between different types of machine learning, the different types of machine learning, they are distinguished based on this input and output. So if the model, there are some models that you need both the input and output variables. So if you have those those models, if you have them, to use them, your data must have input and your data must have output variable. Those type of machine learning techniques, they are called uh, supervised. Just a minute. Sorry. So there are 4 types of machine learning techniques. So the supervised one is usually the most commonly used or most commonly used learning techniques. So it requires that you have, it looks at the relationship between the input variable and the output variable. The output variable in this case is also the target variable. So this is also our target variable. So sometimes this target variable could be of 2 types. It could be one with label or one which are numeric. So for label, they can be categorical, so that logistics regression, for instance, is binary. So it could be binary. It could also be of 3 level. So which means you have a nominal variable with more than 3 levels. So, but for numeric, it has to be quantitative in numbers, so it doesn't matter. It could be continuous. So you have it continuous. It could also be integer, no, not necessarily continuous. So it takes discrete values. So the output variable could be any of these. Any of these. So whether it's categorical or continuous, whether it's label or numeric, whether it's binary or whatever, then the machine learning is supervised. So the machine learning is supervised. It's supervised because the technique can be used to predict the output. If you give any combination of the input, you can use it to predict the output. And you can now compare the output, the actual output, with the predicted output. And that will tell you whether there is error or whether there is, to show you the accuracy. And you can be able to evaluate the performance. So that's the advantage of supervised. You can always evaluate the performance. But the unsupervised machine learning, before I leave that one, so if the output is label or of this type, then we will call it the classification. So supervised can be one classification, and supervised can also be regression. So we can have classification or regression. Classification is when the algorithm, the machine learning techniques, or the model you are using has an output that is labeled. It is regression if this model you are using or the algorithm you are using has an output, and the output is numeric or continuous. So that's very important for supervised. So, but the unsupervised, unfortunately, does not have output. Output is missing completely. So that you only have so in the unsupervised, all your variables, the variables are not classified. So there is no input, there is no output. Or you can also say all your variables are input variables, so no output variable. So all the variables x1, x2, x3, x4, x5, x6. So all the variables, they are all input variables, if you prefer, but no input, no output. All variables are either input or output. In fact, you don't worry yourself to make any distinction between the two. But in the supervised, you have output variables, you have input variables. So techniques that we use this type of model, they are all classified as supervised. So what are the techniques that we use this? For instance, we have identified techniques like regression, and there are different types of regression, techniques. Linear regression, for instance. Linear regression is a typical example of a supervised machine learning because you have the dependent, which is your output, and the independent. Logistic regression is a typical example of a supervised machine learning. So another example of regression, you have, of course, many of them, which we will talk about: subset regression, we will talk about penalized regression, and so on and so forth. There are so many techniques. The same way, there are several techniques for classification. So we are going to look at those techniques for supervision, for classification, those techniques for regression, and so on. But how about unsupervised? Usually, there are only two things that we can do here, or two techniques that we can use. So we can, since there is no supervisor, we can do cluster. So we use so we can use cluster, and then two, we can use principal component analysis. So cluster technique. So we can do clustering. And what is clustering? Is to group these variables, which variables are related. We group them. But there is a distinction between clustering. I will tell you later. So while clustering is for grouping cases, principal component is for grouping variables. We'll talk more about that later. So principal component you use to group variables. Cluster analysis you use to group individuals or cases. So we use the principal component for dimensionality reduction. So we talk about dimensionality reduction. We will talk more about that. We are still getting used to some concepts. So, yeah, so for unsupervised, you can do clustering and you can do association. Then you have the semi-unsupervised learning. So here you have both labeled and unlabeled data for training. So it's not just no separation. You like here you can have either label, which will be classification, or you have unlabeled numeric, which is for regression. So, but in semi-supervised, you can have both. You can have both labeled and unlabeled data for training. So, it's very expensive and time consuming, those techniques, but it exists. The last one, the fourth and the last, is the reinforcement learning. In this type, the algorithm or the model learns by performing an action from experience. The best way to explain this is, I gave example of self-driving cars. They are trained. Using the reinforcement approach. So it's not that you have output per se, but so the algorithm will perform. Maybe it's moving along this path, then it encounters an obstacle. On its own, it will find, once an obstacle, it means it cannot go straight, then it will, on its own, find a way to circumvent that and try another path. So if there is no obstacle, it keeps moving. And then if it encounters obstacle, then it's going to learn about this obstacle and then possibly divert again and then keep moving again, or maybe until another obstacle is encountered here, and then it diverts. So this is reinforcement. So is learning at every stage of the process. You don't have input, output, as the case may be, but it learns. So if you have the car driving and it encounters an obstacle, then there is a sensor that will say, okay, there is an obstacle there, turn to the right. So it turns. So it encounters an obstacle. The sensor also signals there is an error or there is an obstacle there, turn to the left. So it turns. That is reinforcement. So it's learning by at each step, at each stage of the process. So so each stage constitutes an experience. So The significance of machine learning, cannot be overemphasized. So it's a significant shift from how we used to build data and how we used to make prediction. Today we have very complex systems. So machine learning techniques helps us to handle vast amount of data, helps us to learn patterns, helps us to make decisions with very limited human intervention. So this is very, very important, today. And that has really made technology to increase very rapidly. So we have talked about machine learning. Let's talk about data mining. And data mining is about digging into data to discover pattern. Machine learning, as you can recall, is about using algorithm, using model to be able to understand pattern and make prediction. Data mining is about, digging deep, searching the data to be able to discover patterns and trends. So you need to use sophisticated data analysis tools for you to be able to discover this unknown patterns. So to be able to establish relationships, to be able to check, for patterns, you need to use, sophisticated tools. So what are these tools? The tools could include statistical models, mathematical algorithms, including machine learning method. That's where you see the data mining as being more encompassing than, data mining to be more encompassing than machine learning. Data mining is wider in scope than machine learning. Machine learning is actually a subset of data mining. So because in you being able to discover patterns, discover trends, establish relationships in your data set, you have to use statistical tools that you are now familiar with, statistical tools, mathematical algorithms, and machine learning methods. So it's not just about collecting data, it's not just about managing data. So it also includes making predictions. What are the core processes in data mining? Because it's all about data, then you have data cleaning. Your job as data miner starts from being able to remove noise and inconsistencies in your data, being able to integrate data, in other words, bringing multiple data sets together to form a coherent and a very usable data. Data selection. So data miners, they are also able to select relevant data to analyze and mine from databases. Data transformation, data mining itself, which involves applying algorithms to extract patterns from data. Data pattern evaluation and knowledge representation. All of these are the core activities in data mining. They are the core activities in data mining. In machine learning, the core activities, as you will have noted, is for you to train your model, test your model, validate your model. Those are the core activities in machine learning. It's about building algorithms. It's about, It's about building algorithms. It's about, training the algorithms. It's about testing the algorithms. It's also validating, and then using the model for prediction. But data mining is more than that. So these are 7 main activities. You have to clean the data. A data miner will have the capacity, the skill to clean, integrate, select, transform, mine, evaluate, and also represent. So, of course, just like machine learning, I've talked about classification. Data mining methodologies will require that sometimes you want to do classification, sometimes you want to do clustering, sometimes you want to do association rule learning, sometimes you want to do regression, sometimes you want to do anomaly detection. So these are key data mining methodologies. So, classification method will categorize data into predefined groups, categories. Clustering is going to break the data into categories. Association rule learning is going to identify interesting associations and relationships in large data sets. Regression, this association rule you all use is common on merchant platforms where you buy products and so on. The association rule, which is a recommender system, will tell you that those who bought this particular product also bought this one. Those are association rules. So trying to map customer characteristics, preferences, with their choices, with their socioeconomic characteristics. It could be regression, which is to model relationship between variables. It could also be to carry out anomaly detection. Anomaly, they are unusual observations of unusual data records. So objective might be to detect those anomalies. Maybe in admission records, you want to detect unusual, maybe in health record, you want to detect unusual patient records. So these are usually data mining methodologies. And the significance of data mining include predicting future trends. You can predict what the future will look like. You can also have information about your customer, their preferences, to be able to increase your sales and decrease your costs. You may also want to improve efficiency. You may also want to take competitive advantage. So these are areas where you can easily bring data mining into focus. Now, in more detail, let's look at supervised versus unsupervised. I've actually given explanation on all of them, but those explanations, they are also here. So you could recall I talk about classification, I talk about regression. So in supervised machine learning, you train your model on a labeled data set. So if the label you are having is discrete labels, then it means you can use classification techniques like logistic regression. And you have example, classifying whether email is spam or not. So it's a binary classification task. That label is discrete. The output, what you are predicting is whether an email is spam or not a spam. For regression, the output must be continuous, as I said earlier. So example is if you are predicting the price of a house based on the features of the house, maybe how many bedrooms, what is the size of the sitting room, what is how many toilets. Those are the features of the house. Those are the determinants of the price of a house. So for supervised machine learning, email spam filtering, you can do sentiment analysis. In sentiment analysis, you want to determine whether customers' sentiment is positive or negative or neutral. Then you can also use these supervised techniques for credit scoring. In banks, they do a lot with credit scoring. Want to predict the credit risk of customer. Maybe some people, when they take loan, they can default. They won't pay back. That's a big risk to the bank. So there is what they call credit scoring, which machine learning, supervised machine learning technique can be used to do. So it will predict the credit score for loan applicants, and on that basis, you will know whether that person is qualified or can be given a loan. Then you can also use supervised machine learning for sales forecasting. For the unsupervised, no output, but I said earlier, you can do clustering. So clustering is bringing similar objects together, to form a group. So no output variable in any case. You can also use association rules. So a common one is the market basket analysis. So to select, I told you of the recommender system or association rule used on most online marketing platforms. The key differences between supervised and unsupervised. One, data labeling. So in the supervised, the data is labeled. In the unsupervised, the data, no output is even required, not to talk of it being labeled or not. The goal also is different. The goal in supervised machine learning is to predict, whereas in the unsupervised machine learning, the goal is to detect pattern or groups, not to predict. 3, complexity. In terms of complexity, it is straightforward. Supervised machine learning is more, straightforward. Since you have a target, you are able to know whether your prediction is accurate or not. But in the unsupervised, it's very complex because you can create a group. How do we know whether the group you have created is actually correct or not? So there is no way in unsupervised machine learning, there is no way to dictate, or correct, to even know that your model performed well or not. There is no way. So that's the major challenge. So put differently, we can say supervised machine learning is less complex compared to the unsupervised machine learning. Another difference is in the applications. So the applications of supervised, you can apply them differently. So the application of supervised is to situations where you have outcome variables or outcome labels, whereas the application of unsupervised learning is only when you want to cluster, you create groups, or you want to discover hidden patterns in your data. Now, the next issue, maybe before we go, let's have a little break and let's say a few things that we would like to see before we go to the remaining part of the lecture? Any question, any comment so far? Hello, class.
We are with you, sir. Yes, sir.
Hello, sir.
Hello, sir.
Yes,
We are
yes.
getting it, sir.
Hamid, tell me what you have gotten so far.
I've learned about the fundamental knowledge of machine learning and as well the fundamental knowledge of data mining. We have discussed that machine learning has three aspects, three core parts, which are the the learning aspects of and testing, and then the validation aspects. Why data mining is it's it only include the statistical application, statistical method, mathematical algorithm, and machine learning algorithm. So that's the core activities in machine learning as well core activities in data mining. So I've learned about that as well. Other things that I have explained because of the significance, the classification. The other parts I understand them. But I'll still further go and read the note again. I've read it before, but I'll still further read it again to understand it more better. But I've understood the basic knowledge of that machine learning and as well the basic knowledge of data miner. Now, thank you so much, sir.
Okay, so yes, somebody else, I think, SA wants to talk.
Okay, sir. Good morning, sir. So I just have a little question. I need a little clarification.
Excellent.
Yes, sir. So we've been made to know that we have the supervised under machine learning. We have the four different types, which are the supervised, unsupervised, and so on. And you made us to understand that the supervised one is usually used, that the unsupervised is not really used. And you gave us the goals of the two, and you said for the supervised is usually used for predictions, and the unsupervised is to detect patterns. So my question is, what if in a scenario where you need to detect a particular pattern or trend of a data and also make predictions? So can you combine the two learnings, that is the supervised and the unsupervised, to get your prediction and also detect the pattern of the data, sir?
Yes, excellent. So there is no, I mean, if the question is to address objectives that you set, then you can use any tool that will help you to achieve those objectives. So if you have your data set and you want to make prediction, before you can make prediction, it then means you have an output variable and you also have the input variables. So supervised machine learning technique will be suitable. Then you will ask yourself, the output variable that I have, is it label discrete or label continuous? So if it is labeled discrete, then you have to use the classification techniques. If it's labeled continuous, numeric, then you have to use regression approach. Now, if you have another objective, which is to group or to detect patterns, or simply to cluster, to group the cases, then nothing stops you from also applying the unsupervised learning approach. So in a particular study, so you can apply all these techniques one at a time. but it all depends on the objectives you are trying to achieve. Is that clear, Isi? Yeah.
Yes, sir, but I still have one more question. Sir,
Go on.
please, what if the objective does not require clustering, doesn't require grouping? So
Then,
can the supervised learning also be used for to detect pattern, like without using the unsupervised learning? In case we don't have any reason to do groupings in the data.
yeah, so when we talk of pattern, we can also establish, it's about establishing relationship. So even the unsupervised, the supervised can be used to detect patterns. Because when we are talking about patterns, we are saying is X related to Y? And if they are related, then can I use one to predict the other? So that is supervised. So the issue of detecting pattern is quite ambiguous. So, but it depends on what you mean. So you can detect pattern and then go further to make prediction. All the techniques we have to can be used to detect patterns. All the techniques. The only thing is that for the unsupervised technique, you can't use them to predict, but they can be used also to detect patterns, to detect groups and so on. So the unsupervised cannot be used to predict because you can't ever even they don't have output, so they can't be used to predict. Is that clear, Ese?
Yes, sir. It's clear,
Uh-huh.
sir. Thank you, sir.
Or they can be, so supervised can be used to detect pattern and predict. Uh, Unsupervised can be used to detect pattern but cannot predict. Osaremen,
Good morning, sir.
good morning.
Um, my question is, you're talking about machine learning.
Yes,
We talk about the training machine to become acting like humans. Yeah,
yes.
there is this theory, sir, that says that it has been acted in movies anyway. That says that with time, machine will not. Apart from the fact that machine will just start taking jobs like that, with machine will start acting like human to the extent that they'll becomes independent without, and so be it, they will not take control of her like that. I don't know how possible is that like that. So they now we already have that of virus taking over system like that, becoming malfunctional. Can we still have such thing like in machine pattern taking behaving like that, taking control without human intervention?
Yeah, everything, uh, everything created by man, even things that God created, human beings, they have also misused them, abused them. Why do we have nuclear war? Uh, because if God has not given the mineral, the resources, the things that can be used to produce nuclear, warheads, maybe it would not have been possible to produce them. So even things that God Himself created, human beings uh, abuse them or misuse them. How much less of what man himself created? So uh, that's why in the artificial intelligence, in the this thing, um, we talk of ethical, use. Uh, as you continue in this field, and then you need to expose yourself also beyond what we discuss in the class. So there is what we call responsible artificial intelligence. Responsible artificial, so that you are not you misusing, you are not producing things that just to uh, wipe humanity away, but the essence is to help man to achieve his task, is to make life a bit more comfortable, so that industry, you can have robots that will do some of the dirty things that human beings are doing. It's not to take away human intervention. There is that fear, which is there. There is no doubt about it. In fact, some are saying why human beings are now, we are all busy clicking and texting and so on. Machine is busy learning, but we are busy texting. Machine is busy learning. We used to learn before, and then tell the computer what to do. But now the reverse is becoming the case. But that can be discussed at individual level and also at the global level. But the issue is this: for you and I, the lesson is that even though you are learning this thing, your learning must always, you must be continuous. You must constantly learn. But the idea behind all this development is to make life a little bit more comfortable. So not to say you don't need wife again, but you can marry a robot who will now wash your dishes, clean your house, lay your bed, and you can sleep with. Now that's not a responsible kind of thing, right? But there's nothing that cannot be abused. It can go to that level. Does that help, Sareme? Or Sareme, are you still there? Is the class still there?
Yes,
So
sir.
I'm still
Yes,
here.
yes,
My
sir.
data got finished. My data got finished. I tried to recharge
Go
my
and buy data.
my data got finished, so I tried to recharge. No, sir, I am, yes, it's clear, sir. But there's one question I want to ask now. It is the fact that machine is helping, to make man the life more easy or easier anyway. Don't think that it's also laying out people out of jobs. Is that not a
Mm-hmm.
disadvantage too, sir?
Oh,
Yeah, we can continue to debate this thing till end of the world, whether it this thing. But in that case, why are you in school? Why are you still in school, Sareme?
To improve my knowledge. To
So uh, it is because there is still hope that you fit into one major market or the other. That's why now you can work from home. Some people, you don't need to go to. It is because of the development that we have seen. I know many people who are working with foreign companies, but they are in Nigeria. It is because of this development. Myself and you now, we are having this lecture virtually because of the development in technology, the advancement, and so on. Has it really removed the need for a teacher? Oh, sorry, man. Are you saying you won't need a teacher again? Your data has gone again. Maybe we have to donate data to. So it doesn't remove, it doesn't remove this thing. But if you are not upskilling, yourself, I tell you, you won't be able to fit into the modern, job environment. You won't be able to. So it's left to you as an individual either to allow machine to do what you can do, or you should be able to upskill that your service will be needed. Or you get to a level that you can also develop machine to do something for you that will fetch you income while you sleep at home. I think that's how much because of our time. Let's quickly go to any other quick intervention. Yes, Badmus.
Yeah. Good morning, sir. Good morning, Paul.
Good morning.
Sir, based on the question that Eze Blessing asked, then to know the type of ML that can be used to dictate the pattern and also to predict. So before you answer her, the answer that popped to my mind is semi-supervised. So, but the answer that you gave her is like that she can strictly use supervised learning. So I want to ask now that can we use semi-supervised? Because according to what I learned today, was that we can use semi-supervised to predict, supervised to predict, while unsupervised you can use it to discover the pattern. So
Yeah,
I'm
yeah.
now
So
asking now.
you are correct. So where you have both a situation where you have label and unlabeled, that's what semi-supervised will do. You are correct.
Okay, sir. Thank you, sir.
Yeah, excellent. It means you are following. So, sorry. Great. Let me again share my screen. We have less than 30 minutes. I have another meeting at 10. So we have to round up quickly. I think we stopped. Yes, we stopped here. So what are the key issues in machine learning and data mining? Very important. One key issue is the data quality. We know data mining, I told you, is more encompassing than machine learning. In fact, machine learning is just a subset of data mining. So data is of essence. Data is central. How many of you listened to my radio program yesterday? Did you listen?
Yes, sir. These things are.
Eh?
I
Did you?
I listened to it, but not all, sir, because I data
Too bad.
not all.
Too bad.
Hello, sir.
Is
I
it
listened
because
to
of
it, but
data that? Is it because
no,
of data?
not because of data, but or because
Because
of chance. Like there was not enough chance, but I listened to part of it. We are at around that evening time because they sent the link to the group.
okay, so it's every week, every Thursday. So I've shared the link with you on the WhatsApp group.
Since sir.
There will be another edition next week, Thursday. So who is not going to listen? If you are not going to
We
listen,
are going to listen.
okay.
Yeah,
not
we're going
just
to
to
listen.
listen. Try to invite others to also listen, and encourage people to come to our UI Lisa lab to come and learn. They will just pay a token to learn about data analytics, different things, skills they need to learn.
Like, can we also to come and learn, sir?
You
If
can
you are
learn,
interested.
but now we will be asking you to pay a token so that you can learn some things that will make you relevant in the most of the things you can't learn them in the classroom. That's the truth.
Okay.
Yes, there are many things.
We'll come and
So
register.
come to the lab, register, and then we can organize specialized program for you so
Okay,
that
sir.
to make you
Please,
relevant.
can we have a discount, sir?
You will have a discount. It's not going to be something that is killing. I mean, people
No
should be
problem,
able
sir.
to pay 5,000, 10,000,
No problem,
to
sir.
learn, to
No problem,
learn,
sir.
to learn
Valuable skill
yes.
and even expensive
Thank you,
skill.
sir.
Thank
Thank
you,
you,
sir.
sir.
Yeah, you're welcome. So let's. So data is very important, and that has been my message on the radio. The title of the program itself is Data Speaks. But yesterday, our focus was the power of data. So next week on, we are going to talk about data for the everyday. So I think you should look forward to that. The age we are is the age of data. And if you are not educated to understand data, you are lost. It's as good as if one has died, but still walking on the street. So, what are the issues with data quality? There are usually problems with completeness, accuracy, as far as data issues are concerned. So there are situations where you have missing data, incorrect data, inconsistent data. These are usually problems. How do we get rid of them? We can do data imputation, we can do normalization, we can clean up, and then do a few other things. High dimensionality is another critical problem as far as data. High dimensionality means when you have too many variables, large amount of data. And then the problem with that, even though it's rich, but the problem is that the variables will be highly correlated. So, and you know the danger of correlation, when several variables are providing the same information. That's what we call multicollinearity in econometrics. It can be a disadvantage, particularly in modeling. So we might need to reduce. So that is what we call high down. There are also cases of sparsity, which do occur. Sparsity makes it difficult for models to learn effectively. So we might need to do dimensionality reduction techniques. One dimensionality reduction technique is the principal component analysis. So we discussed about that previously. Another issue is the model complexity and interpretability. Some models are complex in terms of the specification, in terms of the number of variables that are there, and then some complex model like deep neural networks. They are called black boxes because you don't know what goes on in between. They can predict fantastically well, but you cannot be able to interpret most of the relationships. I don't know. So they are called black boxes. So overfitting, underfitting, there are usually problems arising from large models. So when do we have overfitting? When your model is able to learn the details and noise in the training data to the extent that it performs poorly in the new data. So it's able to learn the noise. You know what we mean by the noise. That is the unwanted part, which we call the residual. It's able to learn the noise and the detail, what we need very well. So it's able to do very well in the training data, but does very poorly in the testing data. That's overfitting. That's overfitting. The reverse is the case. Underfitting happens when the model cannot capture the underlying trend of the data. Is not able to capture the underlying the underlying distribution. Let me use that word. The underlying, the natural behavior of the data is not able to capture it. That's underfitting. So we will still talk more about model complexity. In fact, if you want to do a clean job, try to search for model complexity, then you know and read more about model complexity in machine learning, because it will talk about variance. So I always like this type of diagram. Which one in particular? Yes, I always like this one. Yes. So where it talks about what happens as your model become complex. So this is a typical. So I think you should read about this. Striking the balance, bias, and variance in machine learning. Yes. So here, the error, you have the error in this axis. You have the error on this axis. Let me copy this into our Google Classroom. Okay. So, sorry, before I load that. So you see, this is the error, and this is the model is becoming more and more complex. At this point, the model is very simple. Simple, and then it's complicated further. Then at this point, it's a very complex model. Complex model could be in terms of having multiple functional forms, could be as a result of having high dimensionality, of features and things like that. So when the model is very simple, this blue, is it blue or green? This green line is telling you that for simple model, the variance is very small. And then, of course, the bias is very high for simple model. The variance is very small, but the bias is very high for simple model. But here you have the total error. So total error is the variance plus, is the bias square plus the variance. So that's why you have the total error here. So get me again, the total error, I think I need to, you should read this, I might even ask you, it might come out in the exam. So I'm going to put this in our classroom. You are supposed to discuss this in our WhatsApp group. Now I'm explaining again. Here is showing how you complicate the model, how you complicate from simple, to very complicated model. And this is the error, So you are graphing error and the complexity. How does the error behave as the model becomes complex? So when the model is simple, the variance is very small, but the bias is very high. But as the model gets complex, then the variance will continue to increase, while the bias will be dropping. So for a very complex model, the bias will be very small, the error will be very small, or the bias, so to say, but the variance is going to be very high for complex model. Usually, the total error will be initially, because it's the sum of this and this, sum of this and this. So initially it will be dropping, But as the variance is increasing and the bias, of course, you can see the variance increasing faster. So total error will also be increasing at this point. The optimal level is where the bias and the variance is actually the minimum point of the total error, where the total error is very small. And it's usually the point where the variance and the bias, where they intersect. So if we are looking for the best model is at the point where the variance and the square of the bias are the same. And that gives you the smallest total error. This is what we call the bias and variance, the trade-off between the bias and the variance. So if you continue to complicate your model and make it complex, the variance will be increasing, though the bias will be getting small. In other words, the model will be doing poorly. It will be doing very well in the training data, but will be doing badly in new data. So it won't be able to predict, outside the training data. That's the implication of that. So this thing can be used to explain overfitting and underfitting. Time is going, I need to wrap up. So there are also issues around model complexity, algorithmic bias and fairness, issues about privacy and security. Data privacy is an issue in machine learning, in artificial intelligence. Privacy and security of data is very, very. Scalability and efficiency. There are also issues, read about them here. Ethical and society implications, there are also issues. Somebody raising up hand. Yes, Joseph, quickly.
Okay, sir. My question is merely okay. After running the result of after getting the result of an analysis, how do I know that a model is biased? Merely looking at the estimate from the model, and what are the things I can do to correct the biasness of that model, sir?
So in machine learning, what we use to achieve optimal, model, to determine the best model, is the cross-validation technique. So we will still discuss it when we get there. For now, so the technique is called the cross-validation. Is that clear?
Sir.
Umboko Bank.
Good morning, sir.
Good morning.
Please, can you speak a little about balanced and unbalanced data in machine learning?
We've not talked about balanced and unbalanced data in this discussion. Are you just Umboko Bank?
Yes, sir.
Have I talked about balanced and unbalanced data?
No, you've not. But I think it's necessary at this point.
I don't think it's a big issue in machine learning. Maybe in panel data analysis, yes. In your econometrics, it's an issue. Balance and unbalance. So you are simply is a situation where you don't have the same observation you don't have data for all the time periods for all the cross-sectional units in your data set. So maybe some cross-sectional units, they have data from 2000 to 2015, whereas others in the data in your cross-sectional unit, they have from 2000 to 2022. Then you will have unbalanced. Some will have more observations than the other. But that is not an issue before us in this discussion. Bokobon.
Okay, sir.
Yes. So finally, there are hands-on exercises which I've given to you. You have data on car owners. So you have the data set here, car owners. So you are supposed to download the data, open your RStudio if you have not installed them, and follow these steps to be able to implement my this hands-on. So when we meet, you are supposed to have submitted, and you are supposed to also show me what you have done. I want to see your result and your explanation. You will submit. I think you are submitting them. You are submitting your exercise. Then we have multiple choice questions for you. What is machine learning primarily concerned with? You are supposed to also submit your solutions. So if your solution is A, say A, and then I think Peter, are you there? Peter? Okay. Notwithstanding, so please submit your solutions in printed copy to my office. Just for the multiple choice, just use A or B. Actually, what I would love you to submit is not even the results, but the file. You can send the file to, you can, yes, I will create a place where you will send your result to. You will need to learn how to use R Markdown. These are things you need to be taught, but we can't be teaching you in the class. I think you might need to create time. We can get somebody to teach you in the in the lab. For instance, this lecture that I'm teaching, I use RMark to do it. You can see this is the lecture itself. No, and I can compile it into HTML, into PDF, into Word if I want it in Word. The one you are reading, I knitted it to PDF. That's why you have your own in PDF. And I have the one I'm using in the class as HTML. So this is the end of the class for today. I hope you enjoy it. If you enjoy it, then plan to attend next one. We might have, if I'm free, we might have an extra lecture before the next class. If not, we look forward to the next class. If there is no question, everybody show your camera. Let me be sure you are all around. Show your camera. I just want to show your camera. Wow, these are wonderful people, very troublesome people.
I'm actually working, sir. I'm working.
You are working, really?
Yes, ma. Yes, sir. I'm clearing
Where
Yeah,
is
I'm on the phone joining you.
at my house.
you are in
At my
your
house.
house?
I'm
Yes, sir.
Wow. I'm also in my house. So thank you very much. Enjoy the rest of your day.
Thank you very much.
Take care.
Thank you, sir. You too, sir.
Thank you.